Today we're going to look at the probability distribution function for a discrete random variable. A random variable, generally denoted by RV, is a quantitative variable whose values depend on chance. We use a capital letter to denote the variable and lowercase letters to denote possible values of the variable. So for instance, capital X could be the number of heads you get when you toss a fair coin 3 times. Little x are the possible number of heads you can get, 0, 1, 2, or 3. A probability distribution function, typically known as a PDF, has 2 characteristics. 1, each probability is between 0 and 1. So for example, the probability that you get 0 heads is such and such. The probability you get 1 head is such and such. And all of these numbers have to be between 0 and 1. And the sum of all the probabilities must be 1. The PDF can be given as a table, a graph, or a function. We're going to focus on tables. So here is the PDF of our coin tossing from the previous slide. So we have our x values here, and the probabilities associated with each one next to it. So as I said, the probability of getting 0 heads is 1 out of 8. The probability of flipping 1 head is 3 out of 8. Probability of flipping 2 heads, also 3 out of 8. And the probability of getting all 3 heads is 1 out of 8. And if I add all those up, I get a total of 1. So let's try another one. Sarah plays 3 sports: volleyball, soccer, and tennis. The probability that on a given day she plays all 3 is 15%. The probability that she plays 2 sports is 20%. The probability that she plays 1 is 50%. And the probability that she doesn't play a sport is 15%. So we're going to create a PDF in table form where Y is the number of sports that Sarah plays on a given day. So our tables always start with X and then the probability that capital X equals X. So one of the possible values of X is 0. She doesn't play a sport. And that probability, according to the paragraph above us, is 15% or 0.15. X can be 1. She might just play 1 sport. And according to the paragraph above, the probability that she plays 1 sport is 50% or 0.5. X could be 2. The probability that she plays 2 sports is 20% or 0.2. X could also be 3, and the probability that she plays 3 sports is 0.15. She doesn't play 4 sports, so X can't be 4 or 5 or 6 or anything else. So these are the only possibilities, 0, 1, 2, or 3. And if I add them all up, I should hopefully get 1, which I do. So the next case, it's just a question of which of the following could be PDFs. So we have to remember those 2 rules of what makes a PDF a PDF. The probabilities have to be between 0 and 1, and the sum of the probabilities is 1. Another thing we have to remember is that a PDF is only making sense for a discrete random variable, and the random variable is a quantitative variable. Quantitative means that the values have to be numbers, which means that it cannot be B. I cannot have a random variable whose values are red, green, and blue. They have to be numbers. So B cannot be 1. But let's look at A. We've got values for X, 0, -2, 5, and 7, so it is a quantitative variable. The probabilities are all between 0 and 1, but do they add up to 1? So is 0.2 plus 0.3 plus 0.25 plus 0.25 equal to 1? And the answer is yes. So I'm going to highlight it in red. It could be a PDF. So again, we've crossed out B. So what about C? The values are quantitative, -2, -1, 0, and 1. The values of the probability are all between 0 and 1. But if I add them up, do I get 1? So what's 0.2 plus 0.25 plus 0.3 plus 0.3? If you add them up correctly, you'll notice that it is not 1. It is more than 1, so it cannot be a PDF. So lastly, we look at D. Again, it is quantitative, -5, 10, 12, 14. Those are numbers, so that's good. The probabilities are all between 0 and 1. And if I add them up, do I get 1? So what's 0.15 plus 0.35 plus 0.25 plus 0.25? And we notice that it does add up to 1. So A and D could be PDFs. I don't know what the variable x represents, but that's not what the question's asking. So they could be PDFs. They are quantitative variables. The probabilities are between 0 and 1, and if I add them up, I get 1. Okay, so those are the basics of discrete random variables. In the coming sections, we're going to look at specific types of random variables. So if you have any questions, let me know, but try out the homework, go through it, and good luck.